Hello everyone, welcome again. So today's lesson will be on the Chemical Earth module of Year 11 Chemistry. And in this series we're going to look at bonding and classification. So we're going to look at how different substances are bonded together and how do we classify different substances based on their bonding methods. Okay? So our first section for today is covalent substances. So we're going to look at what a covalent substance is, how do covalent bonds form, and what are the general properties of some of these covalent substances. So here we have dry ice, which is a chemical that you may not be familiar with, but it's actually just frozen carbon dioxide. So it goes straight from gas to solid, and it's used as a coolant, used to cool things, particularly in refrigerators. So dry ice is just one covalent substance that we're going to look at as we go through today's lesson. Okay, covalent molecular substances are first. There are two types, and this is one of them. So covalent molecular substances are chemicals in which the component atoms are bonded with covalent bonds. Okay, which makes sense. A covalent substance is covalently bonded. Okay, that makes sense. But I just mentioned that there are two of them. So the covalent molecular one and the covalent network one. So what is the difference? Well, a covalent molecular substance exists as discrete groups of atoms called molecules. Okay? So, for instance, in an ionic bond, an ionic substance, oops, that's not a C, that's a plus. So each charge is surrounded by 6 oppositely charged ions, and then each of those charges is surrounded by another 6, and so on, up until infinity, or till it ends. Okay? So there's no sense of discreteness. Each part is, one small section of the whole. Okay? Each one interacts with the whole. Whereas a covalent molecular substance doesn't have that structure. If I had say 6 atoms, then they would exist maybe like this, as groups of 2. So each of these group of 2 is completely independent of the other 2 groups. Okay? And that's what a molecular substance is like. While in the ionic substance, 6 of them are all smooshed together and they're all interacting very heavily. These 6 exist as 3 groups which are happy to move independently of one another. Okay? And that's what we call a molecule. Each of these is one molecule. Okay? And because they are all discrete and act independently, then we know that each molecule doesn't interact heavily with other molecules. So one molecule might be going this way, another one might be going this way. They won't even notice each other. Okay? So that's what makes a covalent molecular substance interesting. Each of its molecules act independently of other molecules. Okay? So properties of covalent molecular substances. General properties, not all of them have this, but general ones include low melting and boiling points. So often these substances are fluids at room temperature, and by fluid I mean gas or liquid. So a lot of them are gases. So think oxygen, fluorine, chlorine, nitrogen, neon, I suppose. Okay, not neon, sorry. But those 4 that I mentioned, oxygen, fluorine, chlorine, and nitrogen, all of them exist as gases at room temperature. And they're all covalent molecular substances as well. Okay, so you can see they have very low melting and boiling points. They're often non-conductors of electricity. So here you see that on the outside you've got a covalent molecular substance, and on the inside you've got a metal. And the covalent molecular substance is an insulator, so it stops electricity from getting out and shocking you. Now solids that do form are usually soft and waxy. So you could have wax, for instance, is a covalent molecular substance, and they're often soft and easy and very pliable. Okay, but now we're going to move on to the other one. Well, there was the covalent molecular ones where you'd have molecules that just kind of drift around by themselves. But now we have covalent network substances, so they're a little bit different. So network structures are all covalently bonded, as we mentioned, because they've got the word covalent there. But the component atoms bond to adjacent atoms to form three-dimensional lattices of bonded atoms. Okay, there's all these words here that I'm throwing around: components, atoms, adjacent, three-dimensional. But remember, in the covalent molecular, we had just groups together, so little, aggregates by themselves, and they didn't want to, link together with other ones. They just wanted to be by themselves. Now, in a covalent network substance, you can see that this little guy here will bond to 4 next to it, and those 4 will each bond to 4 more. And each of those will bond to 4 more, etc. And so it's very similar to a metallic or an ionic substance, except instead of ionic or metallic bonds, you've got covalent bonds. Okay? So you can see that they form this network and lattice structure. Okay? Whereas in the molecular case, they would form these groups, and once those groups are formed, there would be no more interaction between any of the atoms. So if you were to think about it, network structures interact, each atom interacts with many more atoms than in the covalent molecular case. Okay? So this means that individual atoms interact with adjacent atoms very strongly, because you can see there's a very strong covalent bond for adjacent atoms. So adjacent meaning next to. So for each of the atoms next to whichever atom we're looking at, they interact very heavily because of those very strong covalent bonds. Now, properties of covalent network structures is that they have extremely high melting and boiling points. Very, very high melting boiling points. And one example of a covalent network structure is silicon, and that's where all our computer chips come from, silicon. They're non-conductors of electricity, or semiconductors sometimes, usually non-conductors. And the exception to this case is graphite. So the stuff in your pencil, it can conduct electricity. So don't go sticking it in a PowerPoint, would be the first thing to tell you. But it's the exception to this rule. Okay? So remember that a lot of times there are exceptions. Usually they're very hard, but they're also very brittle. So diamond is the hardest substance known to man. But if I hit it just right, it will shatter, which of course is bad. Okay? So they are hard, but they're also brittle. Okay? So be aware of that. And in general, they're very insoluble in nearly every substance. There are very few exceptions to this. Okay? So that concludes today's lesson on covalent substances. We looked at covalent molecular and covalent network substances, and we've compared and contrasted how they differ from one another. So we saw that molecular substances exist by themselves, whereas covalent substances like to be linked to every other atom in the crystal or whatever. Okay? So we'll move on to the question segment now, and hopefully we'll be able to learn more about these substances. Okay? So name one substance that is a covalent molecular and one that is covalent network. So you could have picked any of these for covalent molecular: CO2, O2, N2, Cl2, CO, NO2, N2O4, the list goes on and on and on. Okay. For covalent network structures are a little bit harder. So you could pick diamond or graphite, both of them are carbon compounds. SiO2, even silicon, just Si, germanium. A lot of the semi-metals will be covalent network structures as well. Okay, so any of those you could have picked and you would have been right. Okay. Explain why covalent network substances have extremely high boiling points, whereas covalent molecular bonds have low boiling points. Okay. So why if they're bonded with covalent molecular or covalent network, they have such differing boiling points, even though they're all covalently bonded. So covalent molecular substances exist as discrete molecules. So they're little groups of atoms together that don't want to talk to each other, to other groups. Each of these molecules is free to move since it's weakly bonded to other molecules in the system. So they might interact a little bit, but they're very weakly interacting. They don't, not holding each other together. Therefore, in order to boil the molecular substance, very little energy is required to get the particles moving freely. So just a little bit of energy will allow them to, whiz off in their own directions. Okay? Now, covalent network substances have lots of atoms bonded to one another in a big network. In order to allow the individual particles the same level of freedom as a gas. So in order to get each of those particles freely moving like a gas, every single bond needs to be broken. So each of that millions and millions of bonds in your crystal need to be broken up. This requires a great amount of energy, contributing to the high boiling point of these substances. So you can see that breaking a million strong bonds is obviously harder than breaking a million weak bonds. So that's why it takes so much more energy. Okay? Just because now, instead of the bonds being, contained within each molecule, they're actually spread out and kind of branch out into the whole network, making the network stronger than each of these molecules. Okay? Explain why covalent network substances often exist as gases. Well, since these substances exist as discrete molecules, there are weak forces holding these individual molecules together. So the molecules will be held together very, very weakly. This means the particles are free to move when excited by thermal energy. So as soon as there's that little bit of energy, they're going to snap off and fly off in whatever direction they want. The reduced intermolecular forces in these substances are the reason why many covalent molecular substances are gases. Because there's such little force holding them together that they can be a gas, or they can have the same freedom as a gas when only a little bit of energy goes into them. Okay? And that's why a lot of them exist as gases, because of those very weak forces between the molecules. Okay? And why are covalent substances not electrically conductive? And I'm talking about covalent substances as a whole, with the exception of graphite, not just covalent molecular or covalent network. Well, electric current obviously requires the movement of free charge. It needs electrons moving, or it needs ions moving, or if you're a physics student, it needs positrons moving. Not that we get lots of positrons anyway. But it needs a charge that's moving in order to get electrical current. Now in a covalent substance, the valence electrons, so all of the electrons basically, are locked into bonds between atoms and thus are not free to move. So all of the electrons in covalent substances are actually locked in place and they're not allowed to move from place to place. Now additionally, there are no free charges in the form of ions, which will allow the flow of electricity. So because there's now no ions either, we have no movement of charge, and no movement of charge means no electricity. So that's why covalent substances don't conduct very well, if at all. So, question 5. Covalent network substances are often excellent conductors of heat. Explain why this is possible. So in the last question we just saw that they're all covalent substances are all poor conductors of electricity. But it seems that covalent network substances are excellent conductors of heat. So usually those two things go hand in hand. So why would this be possible? Well, since the atoms in the lattice are tightly bonded, vibrations from one atom can easily be transferred to adjacent atoms either through the bond, so the actual vibration of the bond, or if the vibrations are big enough, the nuclei can actually collide with one another. So that quick transmission of vibration helps the heat to move across. So this rapid transfer of vibration equates to a high thermal conductivity. So things that allow the vibrations to transmit very quickly have high thermal conductivity, as opposed to things that cannot let those vibrations move from place to place, thus having a low thermal conductivity. Okay? So that concludes today's lesson on covalent substances. We looked at the two types of covalent substances, covalent network and covalent molecular. And we've looked at the difference between the two and what makes each of them useful or at least different from one another in the way that we use them in industry. So in the future we'll be comparing all the different types of bonding that we've looked at, and hopefully we'll see some differences between the three. So look forward to seeing you at our next lesson.